Hi, I'm Ellsya Dwi Manullang. I will lead the presentation first, and then my friends Natalin Siahaan will continue the presentation. Enjoy it! There's a content in this presentation. First, definition of acid and base. Second, indicator of acid and base. And the third is acid-base theory. Come on! First, we will learning about acid. What is acid? Do you know the definition about acid? Here we are. Let's go! Here we are in the definition of acid. The term acid comes from the Latin acetum, which means vinegar. Acid in chemistry is a chemical compound which when dissolved in water will produce a solution with a pH less than 7. In modern definition, an acid is a substance that can give protons to other substances called bases or can accept the ion pair of a base. Or acids are substances that cause sour taste in various materials. Jadi, dalam bahasa Indonesia, asam adalah acetum pada bahasa Latin yang berarti cuka. Asam dalam kimia ini jika terlarut dalam air dapat menghasilkan larutan dengan pH kurang dari 7. Dalam pengertian zaman modern, asam adalah senyawa yang dapat memberikan proton ke substansi yang lain atau kita sebut basa. Nah, jadi asam ini sesuai dengan namanya, dia berarti berasa juga asam. Nah, we will learning about definition of acid. Next, we will learning about characteristic of acid. Do you know about characteristics of acid? Characteristics of acid. First, a sour taste when tasted. Rasanya asam ketika dimakan. Contohnya, ketika kita merasa jeruk nipis, rasanya asam atau masam. Second, is an electrolytic solution so that it can conduct electricity. Jadi, larutan asam ini dapat menghasilkan arus listrik. 3, burns when toasted, especially with strong acid. Jika kulit kita ini terkena asam, bisa jadi akan menyebabkan rasa terbakar, apalagi jika itu asam kuat. 4. The acidity is less than 7. Jadi, pH dari asam ini lebih kecil dari 7. And the 5. The reaction to metal has a corrosive nature. Dapat kita lihat nih, jika besi yang kita biarkan di luar terlalu lama, itu nanti kan bisa menyebabkan perkaratan. Begitu juga jika besi kita masukkan ke larutan asam, nah lama-lama terjadilah perkaratan. After we learn about acid, next we will learn about base. What is base? Do you know the definition about base? Definition of base. Base or alkali comes from Arabic which means as. In general, bases, namely substances with a bitter taste, are caustic. Jadi, pada umumnya, basa dinamakan suatu senyawa yang berasa pahit. Bases are the presence of a chemical compound that absorb hydronium ions when dissolved in water. Base in the opposite of an acid, which is intended as an element or compound to chemistry with a pH greater than 7. Jadi pH-nya si basa ini kebalikan dari si asam. pH si basa adalah lebih besar dari 7. Do you know about the base characteristic? Here we go. Characteristic of base. First, able to neutralize against acids. Jadi basa dapat digunakan untuk menetralkan asam. Second, feel slippery when in contact with skin. Jadi, jika basa terkena di kulit, maka akan terasa licin. Tapi basa tidak boleh dicoba ke kulit karena itu berbahaya. Third, when dissolved in water, it releases a hydroxyl ion. Jadi di sini, jika basa dilarutkan ke air, maka akan melepaskan ion OH-. Fourth, can turn red litmus into blue litmus. Five, can conduct an electric current. Jadi, basa dapat menghantarkan arus listrik. Next, we will continue about indicator of acid-base. Do you know about indicator of acid and base? Definition of indicator acid-base. Acid-base indicator, also known as pH indicator, are halochromic compounds that are added in small amounts to a sample. Generally, a solution that will give a color according to the pH condition of the solution. At 25 Celsius, the pH value for a neutral solution is 7. Below this value, the solution is said to be acidic, and above this value, its solution is called alkaline. The mechanism of color change by indicators are acid-base reaction, complex formation, and redox reaction. Jadi di sini indikator dari asam basa dikenal juga namanya dengan indikator pH. Dan di sini ada berbagai macam, nanti ada yang ditambahkan dalam jumlah yang kecil. Jadi nanti kalau pH-nya netral itu dikatakan ketika dia pH-nya di sama dengan 7. Jika dia dikatakan asam karena pH-nya lebih kecil dari 7, dan jika dikatakan basa jika pH-nya melebihi 7. Single indicator. A single indicator can only distinguish between acidic or alkaline solution, but cannot know the pH or pOH values. Included in the single indicator are litmus or blue litmus or attraction. Jadi, single indicator itu dalam bahasa Indonesia disebut juga indikator tunggal. Single indicator itu dapat digunakan hanya untuk membedakan mana dia yang asam dan mana dia yang basa, tetapi tidak dapat digunakan untuk menentukan nilai dari pH atau pOH. Contohnya seperti yang di samping ini, kertas litmus. Kertas litmus ini jika dia di asam akan berwarna merah dan jika di basa akan berwarna biru. Natural indicator. In nature, there are many acid-base indicators that come from plants. Part of plants that can be used include flowers, leaves, and roots. The natural ingredients above cannot be directly used as indicator. So that they can be used as indicator, must be made in the form of solution by extracting them. Then, into the natural indicator solution, drop of acid and base solution. The color change that occurs in each natural indicator varies. Next is about pH meter. pH meter is a tool used to measure the pH of a solution by immersing the electrode in the solution. The pH meter will measure the presence of hydrogen ions, which is shown on the pH meter scale. With this tool, it becomes easier for us to determine the acid or base properties of a solution. Next, it's about universal indicator. Universal indicator can distinguish between acidic or basic solution by knowing the pH value of the solution. Universal indicators can be both vapor or liquid form. The last is about indicator solution. The most commonly used indicator solution in various laboratories are phenolphthalein or PP, methyl red, methyl orange, and also bromothymol blue. These solutions are often used in the solution titration process. The use of indicator solution in the solution titration process must be carried out very carefully and with very high observation. This is because the color change will occur with only a few milliliters.
Now we will learn about acid-base theory. There are three theories that identify a singular characteristic which defines an acid and a base: the Arrhenius, the Brustad-Lowry, and the Lewis theory. The first is Arrhenius theory. Swedish chemist Svante Arrhenius was awarded the 1903 Nobel Prize in Chemistry. In 1884, the Swedish chemist Svante Arrhenius proposed the specific classification of compounds, acid and bases. When dissolved in an aqueous solution, certain ions were released into the solution. Arrhenius acid. An arrhenius acid is a compound that increases the concentration of hydrogen ions that are present when added to water. These hydrogen ions form the hydronium ion when they combine with water molecules. This process is represented in a chemical equation by adding water to the reactant side. This is an example. Hydrogen chloride reacts with water that will form hydronium ion and chloride ion. How about arrhenius base? An arrhenius base is a compound that increases the concentration of hydroxide ions that are present when added to water. This is an example. Ammonia reacts with water that will form ammonium and hydroxide ions. The second theory is Bronsted-Lowry theory. The Arrhenius theory makes use of hydroxide ions which may not exist in non-aqueous solvents and does not cover weak bases. In 1923, Bronsted and Lowry put forward a more general theory of acids and bases which incorporates all protonic solvents and not just water. They define an acid as a substance which yields a proton and a base as a substance which can combine with a proton. This is an example of Bronsted-Lowry theory. Water reacts with bicarbonate ion and will produce hydroxide ion and carbonic acid. The water is losing proton, so the water is Bronsted-Lowry acid, and the remaining species that is a proton acceptor is hydroxide ion as conjugate base. Also like bicarbonate ion as the Bronsted-Lowry base, and the conjugate acid is carbonic acid. So, Bronsted-Lowry base and conjugate acid is conjugate acid-base pair. Also like Bronsted-Lowry acid and conjugate base is conjugate acid-base pair. The last theory is about Lewis theory. Another theory that provides a very broad definition of acids and bases has been put forth by the American chemist Gilbert Lewis. The Lewis theory defines an acid as a compound that can accept a pair of electrons and a base of a compound that can donate a pair of electrons. Like reaction above, in A, compound is electron acceptor, that is Lewis acid, and the B is electron donor, that name is Lewis base. So the combine of that compounds are Lewis acid base complex. This is an example. The hydrogen ion reacts with ammonia that will produce the ammonium. The hydrogen ion is Lewis acid and the ammonia is Lewis base. This is the second example. The ammonia reacts with boron fluoride and produce ammonia boron fluoride. The ammonia is the Lewis base because donates a lone pair electron, and boron fluoride is Lewis acid because accepts a lone pair electron. In this part, we will learn about acidic basic strength. How we know the compound is very acidic or slightly acidic? In general, we use pH method. The acid compound has the pH value below 7. The lower pH, the more acidic. The compound is at pH 7 is neutral compound. Compounds that have pH above 7 are alkaline. The higher of pH value, the more alkaline the compound. Strong acid. The characteristic of strong acid is first, strong acids are molecules that completely dissociate into their ions when it is in water. The second, pH of a strong acid solution is very low. Third, acid dissociation constant is a higher value. Dissociation constant is 1. The fourth, release all the hydrogen ions to the solution. The examples are hydrogen sulfide, hydrogen chloride, hydrogen bromide, and nitric acid. The weak acid. The characteristic of weak acid is first, weak acids are molecules that partially dissociate into ions in aqueous solution. Second, pH of a strong acid solution is about 3 up to 5. Third, acid dissociation constant is a lower value. The fourth, do not release all the hydrogen ions to the solution. Examples are ethanoic acid, hydrogen sulfide, and carbonic acid. This is the picture about strong acid versus weak acid. What is the difference about that? Strong acids are assumed to dissociate completely when in aqueous solution. Weak acids dissociate only slightly in aqueous solution. The majority of molecules remain in undissociated. Diagram show us relative concentration of species when strong acid and weak acid dissociate. The same holds true for strong and weak base. This is the differentiation about strong base and weak base. A strong base is a strong electrolyte that can fully ionize to become hydroxide ions and the rest of the base. The strong base is completely ionized in water so that the degree of dissociation is 1. The weak base are weak electrolyte equal to weak acid so that partially ionized in water, alpha smaller than 1 and bigger than 0. The differentiation about strong base and weak base. A strong base is a compound that can completely dissociate into its cation and hydroxyl ion in aqueous solution. A weak base is a compound that partially dissociates into its hydroxyl ion and the cation creating an equilibrium condition. The strong base is dissociated into ions almost 100%. Then weak base is partially dissociated into ions. Strong base is indicated by a pH value closer to 14 and weak base is indicated by a pH value greater than 7 but lower than 14. The strong base is highly reactive and weak base is less reactive. The pKb value is almost 0. Then weak base is pKb value is high. Last is the example of acid and base. The strong acids are hydrochloric, sulfuric, nitric, and anything with a high Ka. The weak acid is ammonium ion, benzoic, boric, ethanoic, hydrocyanic, and strong base is sodium hydroxide, potassium hydroxide, barium hydroxide, and weak base is ammonia, aniline, methylamine, and pyridine.